Okay. Make sure you're taking your quiz, because that's where I'm going to take attendance. Along with when you do your labs, that's when also I take attendance. And I have to certify the roster today for the city or state, whatever it goes for regulations. We have to certify it. That's why I have it set up to finish up at 8 p.m. so I can get all that turned in before late tonight. Also, when it comes to your labs, which is all your labs are going to be due on the date that it's due, such as today at 11:59. I heard a lot of talks that a lot of you are working together, which is great. I love collaboration and helping each other out. But I just want to be clear, turn in separate files, CPP file. I don't mean share each other's CPP file and just change the name on it. I get that once a year that someone gets caught cheating. I know in the lab 1 it's sometimes kind of difficult because it's very short, but I have seen examples where someone sent over someone's CPP file and all they did was swipe the names. And so when I showed it to them, I go, they even had the same spacing, tabbing, and formatting throughout the entire program. So when I printed it out, I could lay it on top of each other and it was identical. And they still denied that they didn't cheat. So when it comes to coding, I do not mind you helping each other out, but please, I'm giving you the 411 on cheating. Do not turn in the same thing. Change it up. Variable names, order, whatever you need to do, change it up so it's not so identical. I don't run it through a plagiarism checker. I don't do anything. It just happens that, oh, it looks familiar when the next one goes down from the queue, and I go like, hey, didn't I just grade this one? Or one time I caught it, someone misspelled something on the screen the same way. And so I'm like, hey, I just saw that typo a moment ago. So please do not cheat, because when it comes to cheating, it's automatically 0 for both people, and that 0 does not get dropped. Okay? So I just want to get that clear. I just want to put that out there. Please do not cheat. So when submitting my lab today, would I only have to submit the CPP file? Yes, we've talked about that multiple times. Just submit the CPP file on Blackboard. You have 2 attempts. So we have a lot to go with today. Let me start sharing my screen. Sharing screen. Share application. Can everyone see my screen, which is Visual Studio?
Yeah, I can see it.
All right. From what we did from our in-lab to everything we did so far, all our coding has been very streamlined. That's what I put here. Execute statement 1, execute statement 2, execute statement 3. What happens when we want certain statements to execute and some of them do not, based upon a certain condition? The way we've been writing our code, statement 1, statement 2, statement 3, we do not have that kind of mechanism in place. For us to do that, we have this new keyword, a new statement called an if statement. An if statement strictly says, if this is true, then execute the single line after, if it's written like this. If this is true, execute this single line. If it's false, skip over it. Even if it's the same indent, skip over it and go to the next statement. If I want multiple statements to be executed if it is true, I would need to block it, which means put the curly braces around it. So if this is true, statement 5 is going to execute, and then so is statement 6. If this is false, statement 5 is not going to execute, but statement 6 will. Everyone got that simple concept?
The question: when do we like have to either put return statement 5 so that the other doesn't return, because wouldn't both of them return either way because of the structuring of the code?
Say that one more time. I want to make sure I understood the question.
Okay, so when because you said that statement 5 wouldn't execute and statement 6 would, but wouldn't both execute because no. If the statement was true, wouldn't both statements run because statement 5 isn't being returned and statement 6 would still do it anyways?
Yes, if this statement is true, both statements 5 and 6 would both be executed.
Yeah, because I was going to say because you're not adding return on it, so it would still do it.
Well, if I had return before anything, return 0, anything after the return would be dead code because it would never reach it. That's going to come up in functions and later on, so let's put that on the side burner. But do you understand the concept right here? If this is true, returns usually later on down here. If this is true, both statements 5 and 6 will execute. Understand?
Yeah, they usually are on the bottom of the main function.
Well, this is all in main. It doesn't matter if this is main or is in a separate function or anything. It doesn't matter where it is. The mechanisms are that says if in this condition, if this statement is true, then execute whatever in this case is in the block, which I can define new variables. But if this is true, everything in this block is going to execute, along with statement 6, because it's outside the block. But if it's this false, these two statements will not be executed, but statement 6 will. Any other questions regarding this simple concept? Make sure you understand this because it's going to start to get more complex a little bit as we go along. From here, go ahead.
So you don't have to add another if statement for statement 6, correct?
No, well, if I want this to execute no matter what, this statement 6 is going to execute no matter what if the if statement is false or true. The only thing that's in question is this block.
Okay, that makes sense.
I do not have these curly braces right here. The only statement that's in question is the statement directly after the if statement. So if I have statement 6 here and this is 7, if this is false, statement 5 will not execute, but statement 6 will, and so would 7. The only one that's in question is the statement, the only single statement afterwards. If you are questioned about clarity or you want more than one statement to execute, always block it in. And this is what good programming practice is. In this case, with the if statements, always block it and put it within question. So now, in this case, if it's false, so statements 5 and 6 do not execute, but statement 7 will. But if it's true, all statements, statement 5 and 6 and 7 execute. Now from there, I'm going to add on, well, what about if there's another one, if else?
Ooh.
In this case, if this if statement is true, statements 5 and 6 are going to execute, but the else block will not. But statement 8 will. So it's either one or the other, if or else. If it's false, statement 5 and 6 will not execute, but 7 will, and so will 8, because it's outside. So any questions on that?
I don't.
From now on, there could be a series of if statements. It could be an else if statement here, an else if statement here, and so forth, and it could even have a trailing else. In this case, one of these will execute. So let's say if we put statement 8, statement 9. This is statement 10. But it's going to look in this logic to say one of these has to be true, and I'm only going to execute that one code. So let's just say if this is true and this is false, let's just say this is true. This is false. This could also be true. This could be true or false. Because what it's going to do is going to say, I'm going to find the first true statement, true if statement, and only execute that block of code. So in this case, this is false, so I'm not going to execute this one. So this is true. I'm going to execute statement 7, and I'm not going to care what any of the other statements are, and I'm going to go straight down to 10. That's why I said this could be true or false. I don't care. I'm going to find the first true one, and whichever was true, I'm going to execute that block, and then go down to the next statements after the if-else statements. Any questions on that? Good. So I'm going to change this up. So if you can understand these simple concepts, you got chapter 4. So in this case, this is a strictly if statement straight out. So I'm going to test each of these. So this means, unlike the if, else, if, else, if, else, this can possibly be, statements 5 and 6 could possibly execute. Same thing with 7. I'm going to evaluate all my if statements. So chances are multiple ones could be executed. But in the if, else, if, I'm only going to find just one. Got it? And let's take this a little bit more. I can nest these. If statements. Statement 11. So in this case, for me to get into this nested if statement, because this is if with inside if, this must be true for it to go inside and evaluate. For statements 5 and 6 to be executed, they have to be true, but I'm also going to execute statement 11. But if this is false, I still go inside here, but this is false, so I'm going to execute statement 11 and then do whatever logic is afterwards. In this case, I'll evaluate this next if. But you can nest if, you can nest if with an if with an if. Got it?
Yes, I do.
Okay. If this is a key concept because you're going to do this for your labs throughout, And all programming things from there on out, you're going to occasionally write an if statement and need to know how it works. Before we go to the slides, let's look on comparative operators. Most of the time you would use relationship operator that you've seen before, greater than, less than, greater than or equal to, not equal to. You can, on these statements that we just saw a moment ago, these are simple, but you might test expressions that you write to say if x is greater than 2 and so forth to evaluate to be true or false. And you combine other operators like y is greater than, so forth. To do that, you use these logical operators. Can you see everyone see this spreadsheet, or do I need to make it bigger? This right here, we don't care what value 2 and value 1 are. Remember I said before, any non-zero in C and C++ is treated as a true. Unlike Java, where these logical operators must return true and false, C and C++ for this class, any non-zero is treated as true. So this right here, the ampersand is what we call a logical AND, which means both values must be true for the result to be true. Does that make sense? Both operands, value 1, value 2, it could be value 3, and so forth, both of them must be true for the result of that operand to be true. And also within C and C++ and other languages, there is a notion of short circuit, which means if I find something that makes a statement false, I'm not going to evaluate any further. So with that being said, 0 is treated as false and any non-zero is treated as true. Class, you got that? I repeat that multiple times.
Yes.
So in this case, value 2 is false. Do I care what value 1 is in this case when it comes to an AND?
Yes,
Why do I care?
because they both have to be true for the statement to continue what is within the if statement.
That being said, both of them have to be true, but if I know one of them's false, do I care what the other one is?
Oh, no.
So I don't care, and the resultant's false. Right? It's false. Same thing with this one. I did all combinations. Since this is 0, and this is technically true, but it's short circuit, I don't care. So it's true. It's false. This is a non-zero, which is treated as true. So therefore, I do care with what the next one looks like. So I have to evaluate it. There, I see it as false, and so it's false in this case. Because like you said, both of them have to be true. In this case, 5 is a non-zero, it is true. 1 is a non-zero, it's going to be true. And T, I'm going to put T for true. I'm putting this interchangeably so you know that any non-zero is treated as true. Everyone understands how now the logic AND works. Both values, or all values, because you can have this as cascading as value 1 and 2, value 3 and 4 and 5, and so forth. As long they all have to be true for it to be true. But everyone understands this concept. Okay? Now, the pipe symbol, which is right above the enter key, which is like usually the vertical line that's broken, is a logical OR, which means one or the other or both can be true. Like we mentioned before, if one or the other or both can be true, it does a short circuit as well. So in this case, the first one is 0, which is 0. do I care what the next one is? Do I have to evaluate what the next one is? Anyone?
Yes, you have to.
You have to. So this is false. So this is resulted as false. Right now, this is false, and then this one's true. What's the result on this case?
True or 1.
True. This one is true. Do I care what this value 1 is?
Well, that one's false.
Yeah, but do I care what it is? Because I
No.
already have one.
No, you don't.
I don't care. Same value is true. Same thing with this one. This is true, and then this one's true, but I technically don't care because one of them is logical OR. Only one needs to be true. Let's go on to this one, which is what we call the not operator, which simply inverts the value. If it's false, we
facts.
do what?
Facts. No, I was saying, yeah, not. It's the opposite.
Yes. Whatever it is, if it's false, I get true, and it's true, I get false. I have written, and you sometimes will see logical ands and ors and grouped together. So if you know how it works, then there's no way a person can trick you if you know how things work. Just like we saw right here, for value 2, value 3, value 2, value 1, all this is combined. But as we mentioned before, C and C++ and Java do short circuit. So if we find, and all these are ands, so with that being said, all of them have to be true, but the first false one we get, we don't care about any other logic or any other value. So if this is false, we don't care, 0. Same thing on this one, we got 0, we don't care. This one, 0, we don't care. Same thing. But now this is true, we have to look at the next one. The reason why this is important because sometimes there could be nested code inside here that might be executable. So be careful. So in this case, if this is true, we're going to execute or look at the next condition. Since this is 0, we don't care about the third one. Same thing, we don't care about the third one. In this case, this is true, we have to look for the next one, This is false, so it's still false, 0. They're all true that we have to look at it, and then that's true. No matter how complex these start to get, as long as you know how these logical operators work, I cannot trick you, is what students say. With this being said, this is all logical ORs. So what does logical OR tell me for review? What does logical OR mean?
It means that either one of them is true, then it's logically true.
The whole thing is true. So in this case, value 3 is 0, so I must look at value 2. Value 2 is false. I need to continue looking. So in this case, all of them are false, so it's false. In this one right here, same thing. I have to reevaluate. Ooh, I got a 1. It's true. This one right here is false. This is true. I don't care. Even though it could be true, true or false, I don't care. I found my 1 that I needed. Same thing with this. This is false. This is true. I don't care what the other one is. Since the next one is true, I don't care. That's 1. Same thing with this 1. Now, whatever combination it is, I find my 1 and I can move on. Understand how these logical operators work. If you do, we've pretty much completed chapter 4. So let's go on. Go ahead. Any question?
You said this type of logic is called short circuit logic, right?
Short circuit, which means like like on this one right here that's highlighted, if that's 1 and it's all OR, I don't care what this is. We call it short circuit because you don't have to evaluate. You don't have to go any further.
What is a different type of logic called, or like something. So like in comparison to what you'd say, if a different language has a different logic where it would evaluate all of them no matter what would that be?
Most languages have a short circuit when it comes to logic operators, because with the ands, if they find the first one that's false, they don't need to go on. Why would they, on this case, if let's say with logical and value 3 is false, why do we need to go on and evaluate the others?
No, I'm just asking, is there a name for what would you call a language that doesn't operate in that fashion?
I wouldn't know. A full circuit? I don't know.
Okay.
And lastly, on the one thing I wanted to point out with this if statements, before going slide, this is not a syntax error. You put this as true, you put this as false, and you put this as a semicolon right here. False. Oh, false. It's not a compilation error. It's going to like pretend like this doesn't exist and execute the statements regardless whether it's true or false. So be careful of the semicolon here. All right, let's go to the slides. And then after this, we'll go over your new lab, and then we'll call it a night. Oh, that's lab, lecture 3. Can I download it? Yes, I did. And since we talked about it, this would be pretty quick. Please speak up if you have any questions. You don't have to necessarily message, just speak up. Slideshow. Start from the beginning. Making decisions. The way we make decisions in our if statements is using relationship operators. You have seen this in math. Greater than, less than, greater than or equal to, less than or equal to, equal to. Remember, here's our equal to. It's a double equal. Some languages have a triple equal, which is not only are we comparing the value, but we are comparing the data type as well. And the exclamation, the not equal to. You'd be very familiar with these. Boolean expressions return true or false. But keep in mind, an expression that returns a numeric value of non-zero, like if I did this once before, if I do this, x is equal to 10, no semicolon. This is not a comparative operator, it's an assignment operator. And sometimes, do they fix that warning message? I don't know. See, potential fix to fix this issue. This is assigning 10 to x, and then it's going to be 10, which would be a non-zero. So be careful. It's not a comparative operator. This is an assignment operator. So be careful of that as well. So examples, 12 greater than 5 is true, and so forth. It returns true or false. And this is just an example right here. If x is 10, x is assignment equal to 10 is true. Notice that's double equal, not a single assignment operator. X not equal to 8 is true, and then the double equal sign is false. So we're using relationship operators to compare whether things are true or false, and that's most of the time what you do when you test if conditions. Same thing like when you do our ticket sales. What do we want to handle if ticket sales are negative? So that's how you would compare values. You can assign results to a variable. Like the result in this case would be true if x is less than or equal to y. And it return false if not. So it's going to, if you hover over true or false in C++, you will see a 0 or 1 in the background. That's why they're treated as ints. Do not confuse the assignment operator, which is the first one, a single equal sign, and the equality check, which is the double. Do not confuse the two. This is what we talked about before. Allow statements to be conditionally executed or skipped over. Models the way we mentally evaluate. If it's raining, take an umbrella. If it's cold outside, wear a coat. This is the triangle that we're going to start putting in our flowcharts to say, if it is cold outside, branch off here. Wear this and then come back. So this is where our flowchart is going to be changed. So now when you code, you're going to code one scenario going straight through, and then you can test another one going back this way. So remember, you have your flow of your code changing. You can add more stuff here, but remember, wear a code, wear a hat needs to be in curly braces. So the general format of an expression is an if expression and a statement. Like I said before, if you do not have the curly braces, the only statement that's in question is the statement right underneath the if statement. Unlike other languages where I think it's Python that doesn't use the curly braces, but it's everything that's indented. So that is not the same logic here. It's only questions a single statement right after it. If the expression is true, it's executed. If not, it is skipped. And here's just an example. Once they enter the scores, they average it up. If it's greater than 95, notice they didn't have any curly braces, which good practice in these languages that do block scope. Please put the curly braces in. Curly braces, and right here, if this is true, if average is greater than 95, in this case it's not. This condition right here is not printed off, but it goes down to the next one. If it is true, see out is displayed, congratulations, that's a high score, and then it's returned. Here's the flowchart, if you want to see how it looks. The flowchart will be very helpful when your programs get more complex, because as you code, you can start testing incrementally. You can start testing right here, test this path, then test this. So here's your two test cases that you need to test. First, code and compile this one, code and test this one, and so forth. Do not place a semicolon after the expression. Place statement execution on a separate line. If score, grade 90. Be careful to testing floats and doubles for equality. 0 is false. Any other value is true. So if you use a Boolean in your if statement, be careful, because if you assume it's going to be 0, it's a numeric value, it may not be, because it could be 0.0.0.0 all the way, and there'd be like a 1 at the far end. So be careful using floats and doubles. Not for necessary for greater than or equal to, but when you do, like before when I did it as x equals to 10, be careful and stuff like that. To execute more than one statement as part of the statement enclose them in brackets. This gives you block code. Be careful, this is going to come up when you do variable, life of your variable, and scope. So keep that in mind. Block right here. I'm putting that in your mind right now. Block scope. What else was I going to say? Even though I said it before, in this case, even if it's just one statement after the if, you don't need to put the curly braces, but it's good programming practice to do that. In one of my previous jobs, they had this third-party tool that scanned our code. And one of the conditions that was catch, if you had a single if statement with a single statement outside and you didn't have a curly braces, it would call what would give out as code smells. even though it's logically correct, it was bad style of writing code because these brackets help with, for not necessarily just if it's more than one statement, for clarity. So keep that in mind. Because one time I got lazy and didn't put it in, but then they flagged me because I had a code smell because I didn't have the braces. The if-else statement provides two possible paths of execution. Performs one statement or block if the expression is true, otherwise it does something else. We saw this a moment ago. If the statement is true, statement 1 is executed, but statement 2 is not. If this is false, then statement 2 is executed and it goes on. We just mentioned that a moment ago. Right here, here's a code, enter an integer, and I will tell you if it's even or odd. You type in a number. Remember, modulus does remainder of integer division. So if this comes up, number modulus 2 is equal to 0, it is even. Else it goes down to the odd. Here's the way it works. True, flowchart right here. False, it goes down right here. But it joins at the same execution and goes down to whatever's next. That's the way it looks like in the flowchart. Here's another example. You cannot divide by 0. So they're checking the numerator, denominator first, and if it's 0, they log the information before an exception would be thrown. So either the first statement, block code, how it's nicely blocked right here, multiple statements, else it does this. But either way, if or else it gets executed, they're both going to join at return 0. An if statement that is nested inside an if statement, and a nested if statement can be used to test more than one condition. Woo! Look at these flowcharts now. This gets fun when the designer gives you this or the lead gives you this and he'll say, here's your schematic and what you need to code. So you're going to go right down here and here's all your testing scenarios. Say if it's employed, you don't care what all the other logic is. They're just going to give you these values and say, if this is set, go down here. Now, if this is set to Y, here's your true. Then here's another condition. Then if it's false, go down this direction. If it's true, go down this direction, but you all join up. Does anyone have any questions on this? As you can see, the flowcharts can start to get more divergence. It doesn't converge on a single point, it starts to spread out. And here's how the code is written. If I'm here, then go into this logic right here. If this is false, then skip this and go to the next one. Another example, if it's employed, if this is true, then it either executes this one or this one, but when it gets out, it's going to go outside this else statement. But if this first if is false, it's going to go straight down to here. So as you can see, how you write your code with the curly braces and the indents, how easily it's readable. If everything was flush to the left, it would be troublesome how to debug this. Even though the IDE, you can click on the braces and it would match up the ending ones, but visually, if you see this, and this is the way you should write it, you visually can see it. If this is true, here's my indent, and all the code right here is in question is this. It's indented. And a lot of time when you do code reviews lately that I've been through, this is big, including spaces here and so forth, but I'm not going to be that crazy. But yes, Some developers and some people who look at your code are very picky on spaces, indents, and formatting. So start getting good practices now. We just talked about this, proper indents, it adds clarity. The if statement is what we mentioned earlier in lab. All it does is sees these conditions of if-else statements and looks for the first true statement and executes that block, whether it be an if-else statement or an else, and bounces out. That is all. And this is what the bullet points are. Test a series of conditions until one is found to be true. One. It could be the third one, it could be the 10th one, but as long as it finds one, it's going to stop evaluating the else if statements. It finds once, executes that statement, and leaves. Often simpler than using a nested if else statement. Can be used to model the thought process. If, else if, dot, 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 all the way to if, and it can be a trailing else. If this if statement is true, I don't care about anything else. It's going to just execute statement one. That's the key difference between else if statements, else if statements compared to just straight ifs. Else ifs finds the first true statements and executes it and skips the rest. Here's an example. Notice like these are capital, so we know they're going to be constant somewhere. If this 22 line is true, I don't care about 24, 26, 28, anything else. Once this is true, I bounce out and go to 32, whatever is the next line. If 22 is false, I must look at 24. If 24 is false, I must look at 26. And if 26 is a magic number that's true, I execute that statement and leave. However, I don't need this trailing else. I don't need it. It's good practice to put it in. Because if this is true, if this is false, this is false, this is false, this is false, nothing gets executed. This could be a last case scenario or a catch-all in case you miss a scenario. Good practice to put the else statement in it, but it's not required.
So will you have to put CN for user inputs in between all those as well?
No, because technically beforehand, CN is written up here. It's going to read in the test scores, and this test scores is evaluated.
Okay, that makes sense.
This is just in there. I hear the trailing else is optional. It's good practice. Sometimes I use it as the last option, as in this case, as the grade is F. Sometimes I have used it to log something, say, in case I miss some scenario that I'd never seen, I'm going to have this trailing else as a catch-all. So I can log it for debugging purposes and say, I tested all scenarios, but in case I miss something, I'm going to put this trailing else in. The notion of a flag is to have something has occurred. It's traditionally a Boolean. Think of it, well, it's been a while since people eat at restaurants, like at Poncho's, where you put the flag up if you want something more. All the flag is if something occurred, raise it. Hey, something occurred. I saw this sentinel, or I saw this occurred earlier on. I want a flag to know that later on in the code, it did happen, so I'm going to use a flag. It could flag to say something that occurred, I need to stop the loop, whatever. It's usually a Boolean flag that says something occurred, a condition is met. A variable that signals a condition, usually implemented as a Boolean. Yes, because you don't care. All you want to know is, did it happen? True. If it didn't, false. The value 0 is considered false, non-zero is treated as true. As with any other variables and functions, must be assigned an initial value before it is used. Because you never want, and there is a tri-state Boolean in Java, which can have values of true, false, and null. So normally you must initialize flags to begin with. either as true or false, or 0 or non-zero. But they should be initialized. Logical operators, we
How would
mentioned
you write
before.
that?
Go ahead. What?
So how would you write it
How would we write what?
to initialize that flag? Would it be bool false 0?
Yes, however logic you want to happen. So you would type a Boolean, whatever your flag name is, assignment operator, true or false.
Okay.
However you want to do it. Do you want to initiate it as false and not it, or it all depends on your logic. It's usually true and false, however you want to see fit. Logical operators, we talked about this. The ampersand is and expression that if both values must be true, the logical or one or the other must be true for it to be true, and the logical not, our unary operator. Let's just go over a little bit of these. We'll just go over some of them. Right here, x is 12. X is greater than y, which is, this is true. We must evaluate this. Since this is also true, it's true. That's why I did on the spreadsheet value 1, value 2, and value 1. I don't care what these are. These could be relationship operators. They could be whatever you want. That's why on the spreadsheet I just put as true or false. I don't care. The whole process was if this value is true and this is an and, I must look at the next one. If this is false, I don't care what this one is. But you can, at the very end, not the operators. So you can say take x right here, greater than or equal to z, and then not it. X is 12 and z is 5. So x is greater than or equal to 4, negative 4, which is true, but then I not it. Which this expression is true, not it would be false. Any questions on the last one? I didn't want to go over all of them because you know how the concept works. From the previous slide before, now they're making complex logic instead of making it a single if statement, a single condition. They're combining statements. So now if it's if employed and recent grad, do this. If this is false, then the else is executed. If this is true and this is false, if this is false, I don't care about checking this. This is executing. If this is true and then this is false, else is executed. The only way this if statement right here is executed if both of them are true. So as you can see, you can write complex logic. That's not necessarily complex, combined statements in one if statement. I have written where these if statements span multiple lines, 7 to 8 lines. This and this and this, or this and this and this and not. It depends on how complex logic it needs to be. Is it best to write it this way or a single if statement? It depends on you. They both will work the same. You just have more if conditions to write. My motto is on some things, if one of these can be rule out a lot of conditions, I'm going to test that first so I don't have to write a lot. And so sometimes Sonar, which is our third-party software for when I worked at a previous job, it didn't like that. But for me and other developers, instead of having if condition with 7 ands in it or ors, if I could test an object for null, and if it is null, bomb out right away, I would write that first compared to putting all that in one complex statement. So whatever you decide to do, be consistent and make sure it's clear. Same thing right here. If income is greater than min income, or this years, if one or the other is true, this is going to be executed. The only way the else is executed if both of these are false. You can write, in this case, you can come up with this other logic. Join, notice with parentheses, they made it clear. So inside they tested this income greater than income or years. This is checked and then they not it. So there's multiple ways of writing your relation operator, your condition operator. It's up to you how you want to write it. There's multiple ways. The not has a higher precedence because on the order of operations, they said unary ones are higher operator than binary, and binary is higher than tertiary. In this case, since the not operator is a unary operator, it has higher precedence followed by the and then the or. If the value of the expression can be determined by evaluating just the sub-expression on the left of a logic operator, then the sub-expression on the right side will not be evaluated. This is what we talked, there's a short circuit. Checking numeric ranges. You would use the and or. Use to see if a value falls inside a range. When you use the inside the range, you want to use the and operator. Like for your grades, as max, min and max is 0 through 100. Grade is greater than or equal to 0, and grade less than or equal to 100. That's an and. Think of a number line. You have two dots, 0 and 100. That's equal sign, so you fill in the dots and you fill in the center in the middle between the two. However, if you want to check out outside the range, you must use the or because you have two sets of numbers that you need to go through. So grade is less than or equal to 0, or grade on the other side, but nothing in the middle. And make sure you can't write your grade logic like this. Write it, you can only write it simple like this. Menu-driven programs, program execution controlled by a user selecting from a list of actions. A list of choices on the screen. Menus can be implemented using if-else statements, if-else-if statements. Because you got to think, if you have options of 1, 2, and 3, only one of those can be executed. So it screams out to be an if-else statement. Only one set's going to be executed. Menu-driven programs, organization displays a list of numbered or lettered choices. Prompt the user to make a selection, test the selection in expression. If it matches, execute that line of code. Woohoo! From now on, from any of your next labs and labs that we do, you must do data validation, which is validate the data that's coming in. For example, when we wrote the tickets lab, we have a problem because you can't sell negative tickets. So we should have wrote a condition that says, hey, if the value is incorrect, stop them right there and don't allow them to go on. Let me reemphasize that for your future labs. If data validation is incorrect, do not allow them to proceed. This is what later on in programming languages at university level, they teach you to make this an impossible rule. If I allow them to enter that invalid data and I allow them to pursue on, I have to put a lot of logic in place to correct that data or handle that bad data. Bad data in, bad data out. But if I stop the user or stop that error from happening, I don't have to put a lot of logic in place to handle it. For example, same thing when you do forms, when you do online, when they type in the email address. If the expression doesn't match a valid email, they're not going to allow you to submit that form. Or if any form or any data on that form is incorrect, they're not going to allow you to submit it because they don't want to handle all that logic on the back end. They're going to validate all your responses as it comes in and make sure it's valid before it goes on. So it's very important that you do data validation or validating user input. You can provide various tests, ranges, for example, negative tickets. In this case, I think I think you have the hotel room which has number of floors. Reasonableness, valid menu choices. If the value options are 1, 2, and 3, user types in 10, it's invalid. And of course, divide by 0. And here's what they're doing right here. Test min scores. If it's outside the range, if it's inside the range, execute this statement. Else, they go on. Let me be clear when you start doing our labs, which we discuss after this, that if the user types in invalid scores here, let's say they type in -5, it's not going to go into this block of code right here, and it's going to go to this block, and it's going to continue on. There's no looping mechanism to keep them here until they enter a valid score. That is next chapter when you talk about looping. But for right now, we can write a condition that says, hey, you entered in bad data. I'm not going to process that data. I'm not going to go through all this processing power right here to check all this stuff, knowing that it's not correct. I'm just going to give you an error message and say, hey, you did bad. You can compare not only numeric values, but you're going to compare them on, you can also compare characters and strings, but it's going to be based upon ASCII, American Standard Code for Information Interchange. I think that's what ASCII stands for, or Information Interchange. But when it comes to characters, there's a numeric equivalent for each character on the keyboard. So all this is saying is you can compare characters as well. That's what example right now they're doing is they're comparing characters. Notice when they use characters, char, remember I said single byte, single quote. Do not use double quotes. These are characters. Same thing, you can compare strings. They do the same thing. ASCII equivalent to each character. Same thing. These are strings. Oops. Strings, so double quotes. Strings, double quotes. Chars, single byte, single quote. This is the only tertiary operator that we have. Tertiary means it has 3 operands. So what it is, it's simple. It's nothing but an inline if-else statement. So if this right here is true, then this part is executed. If this part is false, then this. So here, think of it this way. Here's your if statement because it's a question. Is this part to the left of me true? Yes. Then y is equal to 10. Else, if not, go on the other side of the quote. Z is equal to 20. I don't see too many of these being written. I have seen them periodically. I've written them. It's usually pretty quick. It's a lot clearer to do a simple if-else statement, but I have seen the occasional one of these. If it's a statement right here, then the first one that's executed. If not, that is. It's just a single if-else statement. You can make it more complex by putting parentheses around the first if condition on the tertiary if statement. But in that case, it starts to look kind of funny, so it's just simpler to go back to a simple if-else statement. Here it is right here in code. If min hours is less than this, then they're assigning min hours. Else, they're assigning hours here. They're using it to pass back and assign different things. Just a single if statement. If this hours less than min hours, then min hours is going to be assigned hours. If not, this lowercase hours is going to be assigned to hours. It's just like an inline if statement that can be handled on a single line. And lastly, we're going to talk about is the switch statement. It's similar to the if-else statement. You have this expression right here, which should be an integer, and then the expressions to match. So let's take a look at an example. Right here, enter choice A, B, and C. These right here, you read in a char. These are equivalent to constant int types, because remember, like I said, American Standard for Information Interchange, these are equivalent to constant ints. So if the user types in B, it's going to go into line 16 and say you enter B, and then it's going to break out. You need the break. If you do not have the break between each case statement, for example, if you execute A and you don't have any of these breaks, it's going to execute you entered A, you entered B, you entered C, you did not enter A, B, or C, and then exit out. Any questions? You need these breaks. If not, it falls through. Sometimes you want them to fall through, but most of the time you do not. Expression must be an integer variable or an expression that evaluates to be an integer. Expression 1 through expression n must be a constant integer expression or literal and must be unique in the switch. So these must be equivalent to constant ints and they must be unique. So we have to have another example. If it's left out, the program falls through the switch statement. Here's an example that they use to fall through. If the user enters 100, it goes to line 21 and breaks out. But notice when they entered in 300 or 200, on 200 it prints out stereo sound and remote control. So if the user enters 200, it goes to line 20, stereo sound, no break, it goes to case 100, remote control, then it breaks and it goes out. Any questions on the way that switch statement is? The default case, just like the trailing else, it's optional. Switch statement is a natural choice for menu-driven programs. Well, same thing as an if-else statement. They both are similar. Then get the user input. User inputs an expression in switch. User menu choices an expression, in this case, the statements. More about blocks. We'll see this more in the upcoming chapter. Scope of a variable is the block in which is defined from the point of definition to the end of the block. Usually defined at the beginning of a function. May be defined close to the first. For example, right here, get the number out. This int years right here is defined inside this if statement. So you have scope, visibility of this years through the life of this if statement. You cannot find it outside of this if statement. It does not exist. Once this ending block is ended, this is reclaimed to memory. It's called the life and death of that variable. Variable defines inside that block have local or block scope. When inside a block within another block can be defined a variable with the same name as the outer block. When an inner block and outer block is not available, not a good idea. So what they're saying right here is you have an int number right here, and then you enter a number here. So this right here is scope is from int main to this returning one because it's defined inside that scope. But inside this if statement, there's another number. This number right here only exists with inside this block. It does not, think of it that this number hides this one. It does not know anything about this. That's what it says. When an inside a block within another block can define a variable with the same name as the outer block. When in an inner block, the outer definition is not available. This is not good programming practice to have this. Other languages such as Java will not allow you to handle it because it's going to give you a compilation problem to say, I think it's redefinition of variable, something redefinition. But just to get you more familiar, you're going to come out with more with block scope for the next 2 chapters. So it's a life of that variable. Any questions over that chapter?
No.
No? Did I hear any questions?
I understand the everything that you taught about in that PowerPoint.
Okay, great. And then let's also, since lab 1 is due today, I'm going to go over lab 2, which is due on the 23rd. Yes. So this gives you practice with writing your if statements. Can everyone see it? Let me just make sure I got the right one. I have multiple ones. Which one did I assign on this class? Yeah, lab member status. Okay. This is the way you're going to write your code. Implement the following C++ program for full credit. Submit the CPP file. Partial credit will be given. When flying on most airlines, a passenger can join a frequent flyer club. Benefits are based on the number of segments and miles that a passenger flies. A segment is one-way trip regardless of the number of stops on the route. A round trip is 2 segments. Members are classified as platinum, gold, or silver elite status when they attain a threshold of segments or miles. If the threshold conveys a different status, a member is awarded the higher one. The table shows the threshold number of segments or miles that a segment must have to attain the threshold. Write a C++ program that inputs number of segments and miles flown. For each segment/miles pair, based on the table above, print the elite status with those segments and miles. Check inputs, negative values. Do not worry about character key presses. That's chapter 10. We're just considered about negative values. If the input value is invalid, prompt the user right away. The error message and the way you want to handle negative values is up to you. Output should look similar. I don't think I have an example of a negative one. So if the user enters in a segment flown that's, let's say, a negative number, what do you think you should do?
You should handle it. You should see. You should log that please provide a number and then let them answer again.
Yes, that's exactly what I want. Give them a message to say, hey, you entered an invalid number, please re-enter. In this case, if the user enters another negative number, it's going to go on. So don't worry about that because we didn't talk about looping and keeping them there. That's next chapter. I just want you to catch a single run through of it. Does that make sense?
Yeah.
I just want to do it. Do not proceed on to other chapters and so forth. I just want to practice. Plus, do not glem to go on to segments because what happens if the enter the number of segments is negative, but let's say the miles flown is 75,000. What do you do?
Yeah, that'd be probably an issue.
See, then that comes with the probable question. Do I error out because they entered invalid number, or do I give them the platinum status because they exceeded? That's the kind of innuendo you get when you allow bad data to come in, because now you have to run all this complex logic. Well, which one wins out? So that's why I want you to practice with your if condition writing skills to catch them right away. If the value is incorrect when they enter it, stop them. That's the whole point of data validation. So enter the number of segments flown is 17. Plug them 17. They're a member. Enter the number of satisfying, 24 and 3. Both of these make them both member. In this case, enter the number of segments flown is 118. They're gold status, but the other one says they're 24,853, which makes them gold on both sides. The one example right here was probably better. Enter the number of segments flown is 120. That's above platinum, but the miles is 53234, which is actually 53 gold status. But since they're above 120, they get a platinum. Whichever one of these wins out, segments flown or miles flown, whatever they are, they get the higher status. So if segments only gives them a member status, but the number of miles flown gives them gold, they get gold, and the same thing vice versa. If the miles flown gives them member, and the segments flown give them gold, they get a gold. This program is not written in a loop. So each condition that you're going to test, you're going to have to rerun your code. That's why I said sample output 3 runs. Any questions on this one?
So you said, so
ahead.
if they give an invalid number first, you said, so then you would say type it in again, and if they enter it in again, you just want to end the program correctly?
Well, you don't worry about ending the program. You can allow them to go on. That I'm not going to catch you. What if it, like on this case, if this is 17, and then if they enter negative 17 and they enter positive, and they enter, well, let me emphasize. If they enter negative 17 and you catch them, and they enter a negative number again, and you allow them to go on to say enter member number, and they enter in 2432, and you get member, that's fine. I'm not going to error you out for that.
Okay.
Just to clarify, it's not the number of segments flown or the miles flown, it's both.
Remember, it says for each segment pair based upon the lead status, if the input is prompt the error message. Let me see. If the threshold conveys different statuses, a member is rewarded the higher one. It's not this and this. Whichever one's higher, they went out.
Okay. So if segments flown or number of miles flown is higher, they're going to go up.
Yeah, whichever one gives them the higher lead status, that's the one that wins out. It's not that they have to be this number of segments flown. It's not saying like for gold that they need to have this and this. Nope, they can be segments flown is this, and then the mile flown is this. Well, they will get gold. Whichever one gives them the higher one, that's the one you get them. Any other questions or concerns? This is practice with the if-else statements and range. All right, if there's no more questions or concerns, I'm going to stop recording.